So good morning, everyone. So it's my great honor to present our latest study regarding thermal comfort in open rooms. Then you may ask why open rooms are important. So as we know, like almost everyone need like surgical treatment at least once in our whole life. In fact, each year over 300 million surgical procedures will be performed globally. And surgical site infection varies from 2 to 10%. So this drawing shows the surgical environment in the 19th century. So luckily, like Dr. Lister, Joseph Lister invented this phenol disinfection method. And before they invented this method, and the mortality rate of amputational surgery was 50%. So simply like every second patient will die after surgery. And that's really like indoor environment is very important, and it requires very high indoor air quality. Then, well, what's the thermal comfort? So I just want to see your attitude. So patient safety or thermal comfort, which one you prefer? So do you prefer or prioritize patient safety? You raise your hand. Okay, I see many of you who prioritize thermal comfort in open rooms. Oh, really? I didn't see any. Oh, that's one. Okay, yeah. So yeah, So then no wonder, and So whether this issue, thermal comfort for surgeons, were like overlooked. I mean, they simply like satisfy their thermal comfort during open room because like the priority was given to patient safety. And thermal environment are normally like too warm for surgeons, and we perform like a survey at Norwegian hospital. So about 80% of surgeons, so they were not satisfied with the thermal environment. So this thermal image shows that after like 1 hour of operation condition, and you see the color indicates the temperature. Blue temperature shows the room temperature, and yellow and red shows the higher temperature than room temperature. So objective. So the project is develop and test a new personalized indoor environment solutions, which will provide optimal thermal environment for both surgeons or surgical staff and patient in OR. So we use both simulation and experimental measurement, and we got research, small project funded by Peter Shatter grant. So this photo shows one of our mock-up studies at St. Olaf Hospital. We see not like in 19th centuries, and those surgeons now they use like a full surgical gown and covered with a hood and a mask. So they are not wearing like a froggy like in 19th centuries. So which make the thermal condition even worse. Then regarding our simulation study, so we aim like to find an effective way to increase the heat loss from the surgical team. So we integrated this round nozzle to deliver air jet towards surgical surgeons. And at the same time, we need also to reduce the heat loss from patient. At least we should not increase heat loss from surgical patient, because if we cool down the surgeon, it may maybe a risk of so-called this hypothermia, which increase the surgical site infection by 30%. So the preliminary simulation results shows that when we cool down surgeons, we do have localized airflow distribution, which can even increase somehow the local indoor air quality. Then our simulation showed like a great potential benefit of using localized nozzle air jet to cool surgeons. Then I would like to present our latest study at CBE. So we have tested like 8 localized cooling solutions. So the first one is external nozzle air jet, so which is used to increase airflow will stay close to the surgeon like a body. And then we have tested also like personalized air conditioner, neck air conditioner, and solution 3 is a through back fan. We see like we use like a separated fan to blow room air directly to the body. And then we have a solution 4 is using wall fan also to increase the local airflow, but it's not like as intensive as the external nozzle air jet. And then we have solution 5 is a normal neck fan. And then the solution 6 is the masterpiece of my dear colleague Ed. So we can see like this like a personalized wearable like integrated fan, and also this wearable structure which surgeons they can wear under or within this surgical gown. And basically you cannot see well after, I don't know if you can see okay, you cannot see the point, but so there's a photo so that in fact this should be wear inside this surgical gown. After like you pull on your surgical gown, you cannot see it. So, but you can control the fan speed by controller, and it's powered by normal like a power bank. Then our measurement results indicate that by using this external nozzle air jet, so we could increase the heat loss from height by 160% compared with the reference case. So reference case was that under room conditions was a heat loss from a different part of a human body. So by the way, we use this thermal mannequin from CBE. So this thermal mannequin has 16 body part, which we can monitor the heat loss. And we see that by using this external nozzle air jet, we could increase the heat loss from most of the like upper part of body, and but for lower part of body, there like not much effects regarding this heat loss. Then let's see the performance of the within the gown wearable. So by using this within gown wearable, we could increase the heat loss on upper part of body, and also we could also increase the heat loss from height and pelvis. So we see how it works. So my colleague Ed is tune up the position, and also how to fit the body shape. So it's kind of like ergonomic design, and so he just like illustrate the airflow direction. A few couple like key messages from our experimental work. So the first one is external nozzle air jet may increase the heat losses on height and chest by 160% and 75% respectively. And solution 6 is within the gown wearable may increase heat loss on the back and the pelvis by 55% and 30% respectively. Then we also carry out a pilot human subject test. So as we know that surgeons, they wear the gown, at the same time they also perform surgical like activities. So the metabolic rate varies from 1.8 miles to 3.2 miles. So in this case, I got support from my colleagues here, and we use a treadmill to increase the metabolic rate. So with the speed of around 2 miles per hour, and which can be like equivalent to 2.4 miles. And so we just simulate this activity and this metabolic rate. Then we see like during the walking period, and we see a clear increase of the surface temperature. And when we use this external air jet, we see the color change immediately. So at least a few degrees were reduced from the surface. So which indicate that by using this external air jet, we can effectively remove more heat from surgeon's body. Okay, so it just indicate like my colleague was walking, and at the same time like reading some like the questionnaire questions, and he just do both like tasks. So then conclusions from our preliminary study. So local cooling solutions can increase heat loss from surgeons. External nozzle air jet can effectively cool the upper body of surgeons with simulated activity, and the Weijing gun wearables on the back can cool upper body and height. But as we know that the indoor air quality is also very important. Well, in fact, the number one priority when we select a ventilation system for operating room. And the effect of local cooling solutions on local air quality, especially the effect on the air quality close to a surgical wound. So this needs like a further study. So our further study will be performed at a full-scale OR lab operating room laboratory at NTU. So this OR lab has like 60 square meter, which is about 650 square feet. So it's a video. In fact, I can move it. So we receive many medicine facility from local hospital, Senghu Hospital. So even the surgical lamps we receive from the hospital. So we will carry out the indoor air quality study when we complete this thermal comfort study. So when we finalize the solution to cool down surgeons, we will also track whether this solution will improve even the local indoor air quality regarding like particles, regarding like microbiological conditions, and so on and so forth. So then, in fact, please join the breakout session on indoor environment quality in light studied building types. So yeah, thank you. Any questions?